All right. So we are going to work with, if you're using Gianni or something in Linux, code helps us a lot by translating a tab into 4 spaces. Gianni and Nano do not. Gianni will if you tell it to. Python does not like mixing spaces and tabs. It wants one or the other. The PEP method, the preferred method is spaces. So that's what you should do. We're just used to tabbing in Visual Studio Code, and Visual Studio Code converts it for us. So it's a helper. So how does ARPing work? Well, we have physical connections to all these people, right? Layer 1, we have physical connections. We don't actually resolve a MAC address because we're going to use a MAC address to communicate. ARP, when we communicate at the lowest level we can communicate at, what are we pinging to do communication? What's our lowest level?
For communication, we're using IPs.
Yep, that's as low as we can go. But if I'm pinging one of my servers, this is a logical address. It has no ties to the physical network at all. Something has to translate that to the actual MAC address of my server in the back of the room. So we don't run ARP. It runs automatically in the background. Address resolution protocol. And if we do ARP-A, I think it's ARP-A, we can see that 11, ARP in the background either had it in its cache or found it or yelled at somebody to say, what is the MAC address of this guy? The MAC address then ties down to the physical layer, which then allows the voltage on my little low voltage to travel to the network from my network card to the network card on the server. It actually goes through the switch first and all that kind of stuff. But so here I am. I'm saying I want to communicate with host B. I send out an ARP request. If the ARP request is going to everybody, what kind of a communication is that?
Broadcast.
Broadcast. Everybody gets it. If it's not in my cache, I send out a broadcast because somebody may know about it. In this case, actually, we're getting the ARP reply from the host, but you can get an ARP reply from somebody else too, if they know who this guy is, if it's in their cache. But if nobody else knows about it, including the switch, the ARP reply has to come back from the host. And then it says, oh, my IP address is 10.0.1.11. Here is my MAC address. Well, now I can send my electricity back there or my radio waves or whatever my physical connection is. So we have to have that linking between those layers. Now, the next level of communication we have is doing a host address, right? We're going to ping a host address, and that's what we've been doing. So we have now 2 layers of name resolution. What's the next layer of resolution that we added on here? DNS. Because we have to resolve name to IP address. The IP address has to be resolved to a MAC address, but this is outside our network. So are we getting the MAC address of the Google computer? No, we're getting the MAC address of the next device as we're getting to our router. Because routing is, in a simple way, routing is determining, is that IP address on my network or not? That's the simplest form of routing. And we determine that by this guy. This masks out our network address, and we know that everybody that we're communicating locally has to have that IP address. We don't care about the gateway at that point. The minute that changes to like 8.8.8.8, well, all our computer has to know is that, where is my default gateway? That's all it has to know. It sends it to there. All the other devices in a row automatically transmit that packet using MAC, 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 till it gets to the firewall. And then it translates that IP address logically to the public IP address on the outside of the firewall. And then what goes across the internet is not this. It's the outside IP address of the firewall, because you can't traverse the internet with a private IP address. Nobody would know what to do with it.
Because there would be so many that are the same, because they're all, because
It wouldn't
there
work.
could be.
There could be private IP addresses. There could be a million networks in the world that use 10.0.1 with that subnet mask.
Yeah.
Actually, there's the two most common internal networks that I know of are 192.168.1 or .0. So there's going to be a gazillion of those because those are very common. Lots of routers have those as their default. Yeah. So the internet is designed to work with two different things: public IP addresses. TCP/IP, not the internet. TCP/IP is designed to work with public addresses and private addresses. IP version 4 is. Now, IP version 6 is a whole different thing. I'm going to stop at that point because I will be retired before IP version 6 is any kind of an issue. All right. So now we've gone up and down our little stack of stuff that has to happen. And what Scapy does is allows us to like work with all those pieces, which is pretty cool. So for Windows, you have to have NCAP. You have to have some way to get connected to the network adapter. So NCAP is part of Wireshark. It is also part of, what's the other one? What else? Wireshark Nmap. It's part of Nmap.
ZenMap.
Excuse me?
ZenMap is a GUI for.
Yep. As long as you have those in Windows, there's already a libcap library in Linux that does the same thing and it's built in. But in Linux and Windows, we have to install all that. And we have to install Scapy. Scapy's not installed on mobile distributions. It is part of the Kali Linux distribution because this is used for network testing and all that sort of stuff. So we have to install Scapy. So let's install Scapy. All right, so bring up a command prompt or a terminal prompt. Terminal, command, PowerShell, they're all the same thing. It's a command prompt of some sort. So we're going to do in Windows pip install. I don't know why I have wheel in here, because wheel is not included with everything. Wheel is a different way of installing Python packaging, but apparently we need wheel for Scapy. And it wasn't installed automatically. Interesting. And Scapy for a long time was not part of, oh, that's not need wheel anymore. Scapy for a long time, you had to download it from GitHub and do all this stuff. And finally, they put it into pip, the package manager. Okay, well, I already have mine installed. I did not need to install wheel, apparently. So I'm going to take that out of the directions. Now we have Scapy. First thing we want to do is it says make sure you're on a bridged adapter and all that kind of stuff. Well, we want to make sure we're on a bridged adapter. Otherwise, we really have nothing to scan. So we want to find out what is our network. Well, I already know what my network is. It's 10.0.1.0. We just looked at it. So now we're going to make a network scanner. So we make a little program here, and I usually save these as separate. Some of my students will do like the whole thing in one file. The problem with that is that you can't go back if something breaks. So when I'm developing a new thing, I'll do 1, 2, 3, 4, 5. So I can say, okay, this broke. Let me see where it broke because I can go back to my old one. Now, this is something we haven't used, and maybe we have. This is called a, oh, what is that supposed to be in it? This is called a shebang. Don't you like that term? It's called a shebang. Because in Linux, you can make a Python script executable because Linux doesn't care about extensions. It cares about file attributes. And if you use a change mod to change a Python script to executable, you don't have to put Python in front of it anymore. This part says, oh, this is executable. This is where you need to go to execute this. You need to run Python 3, which Windows does not have that. So yes, is Linux superior to Windows? When it comes to networking and hacking and all that kind of stuff, it's got all that stuff built in. It's all add-ons to Windows. So yes, for networking and this kind of stuff, that's why we use Kali Linux. However, it will work on Windows. We just have to do extra work. We need to import our Scapy. I don't know why it's Scapy.all, but it is as Scapy. So what is this doing here? This one's one we've not done a lot of. This is called importing as an alias. So we're importing this library as Scapy. We could also import each little different part of Scapy that we're using. This just happens to be in the tutorial that I borrowed it from or something like that. I can't remember where I got that. So we are definitely going to do functions in this. Because we're going to scan, right? That makes sense. We're going to scan an IP address, which can be a host address too. Right? And Mike mentioned ARP ping. Well, that's where we're going to start, just with ARP ping, just to get, this is a built-in thing that's part of, I'm typing it in wrong. ARP ping, there we go, ARP ping. And then we need an IP. There it is. So ARPing is a piece built into Scapy that does stuff for us. So far, so good. Now we're going to break this up into modules because maybe we want to use this as a module later on. So we're going to do a main. Which also means if we want to be able to use it as a module, we have to do this whole slash if name equals main. What this is saying is that if this program is run with the main function being called, we run the main function. If it's not being called that way, then we use it as a module and nothing in here gets executed. I think I said that right. Yeah, that's what that's testing for. Are we running it with the dunder main part coming out? Because dunder main double underscore main is what Python actually executes when it runs the main module. Is that right?
It means the current file, Python file, if it had been run directly, its name for Python will be main and it will be equal and will run the function. But if it was called from other as model, it will not run the function because its name will be not equals to main. It makes it possible to use our programs as models for other imported models for other programs.
Thanks, Mike. Now this one, we don't have to loop yet because ARPing has all that built into it. Oh, I'm in my home network. We're defining our network. And so ARPing knows it's going to do everybody. And we've done this maybe before, I don't remember, but this is a way to make the program pause. If you do an input and don't do anything with it.
Mm-hmm.
And because there's nothing else after that, we exit the program. Let's see if we get lucky and everything's working today. Ooh, it did. So ARPing is kind of a neat little scanner all by itself, isn't it?
This computer says WinPcap is not installed here.
It would not be, and it's not WinPcap. WinPcap is an old version of
PCAP.
Yeah, it's an old version. So NCAP or whatever the one I said earlier is the current thing that we use, but they still are looking for that. But that's because Wireshark or Nmap is not installed.
Yeah,
It doesn't have anything to talk to the network.
I don't have permissions here on this computer to install.
Nope. Somebody, some mean network administrator decided that students, if they're going to do that kind of stuff, they need to do it with their own virtual machines. That'd be me. Well, actually, I don't have to do that as much now. It used to be that we had Office people in here and, people just taking Microsoft Office and just say that. So how do we run this in Linux? Well, we have it in Windows. So what we need to do is just type it all over again in Linux, right? Does anybody agree with that?
Copy it there to Linux machine.
Copy and paste. That's what we're going to do. Yep. So I'm going to start up my Kali Linux. We're going to copy and paste it into there. We don't have to install anything because everything's already there because Kali Linux has Scapy because it's a, network defense hacking sort of thing. Yep. So we do need to make sure that our Linux is in bridged mode, otherwise there's nobody to scan. And if we have it in a different mode, oh, I do have it on the bridged adapter, because then you're scanning your local network, which is perfectly fine. It's your local network. Make sure you're connected to Wild West. Scan your network at home. Don't be scanning WNCC internet, or you might have the FBI coming after you. No, I did get a query one day from the network guy. He says, "Hey, is this one of your students scanning our network?" I said, "Yeah, you know it was an accident." He did. He knew what was going on. So I said, "Yeah, somebody just forgot to switch their wireless adapter." This is an educational institution after all. They should be expecting stuff like that, right? That's going to happen. Come on, buddy. Now we're still starting. There we go. All right, so here we are.